evening, everybody. Welcome to the Research and Publications workshop on GIS and Geospatial Analysis for Decision Making. Just to give you an overview, the R&P office, which is known as the Research and Publications Office at IIMA, is geared towards providing some of the cutting edge methodological knowledge to everyone who is interested in this particular field. In this endeavor, we actually do one workshop every month. And this month's speaker is Professor Sandeep Chakrabarty, and he's going to talk about GIS and geospatial data. How can we really leverage them in decision making? Just to give you a brief about Professor Chakrabarty, he's a faculty member in the Public Systems Group at IIM Ahmedabad, and he also serves as the co-chairperson of the IIMA Center for Transportation and Logistics. This is one of the newest centers that we have at the Institute. And so he has done his PhD from Saul Price School of Public Policy at the University of Southern California. And his particular specialist is in transportation planning, urban economics, and public policy with a focus on sustainable urban development. He's well published in several peer-reviewed top journals in transportation and logistics, such as Transportation Research Part A, Transport Geography, and several other journals. He also is recipient of several prestigious awards from the associations related to transportation economics and policy and urban planning. At IIMA as well, he contributes in the teaching with some significant popular courses in urban planning, transportation economics, and many others, right? Without much delay, I would give the virtual floor to Professor Sandeep Chakrabarty. I hope you all make the best use of the workshop, and we are excited to go this forward. Please, Sandeep, over to you.
Thank you, Devjit. And I hope I'm audible clearly. Okay, good. So yeah, so let's get started. This is the first R&P workshop that I am conducting. So we'll see how this goes, and we'll set some sort of basic rules of of how we go forward. Now, let me first share my screen with you all, and then we'll talk about what the basic learning objectives of this session is going to be, what we are going to cover, and also, quite importantly, what we are not going to cover. And then we'll get started from there. Okay, let me share my screen first. Okay. All right. So I hope that my presentation is visible to you all?
Yes.
Yes? Okay, good. All right. Okay, so, as the title goes of this workshop, we are talking about an introduction to GIS and geospatial analysis for decision making. Now, the introduction word is important here because I'm going to keep it fairly simple, assuming that many of you would probably be aware of what GIS is, what spatial analysis is. There could be some level of awareness, but I wouldn't really expect that you have had done or used GIS software or conducted spatial analysis yourselves. So I'll assume that. I will also assume that you all are GIS enthusiasts at some level, which means that after this discussion, I would feel successful if I'm able to generate some interest among the audience here, so that you go on to using spatial analysis or spatial thinking in whatever that you do as a student in your own research, or as faculty in your own research, or even as a practitioner in the kind of work that you do, right? So that would be my aim. Okay, so moving ahead, what we are going to discuss in this session, or a couple of sessions, involves the collection and use of space-time referenced information. Okay, space-time referenced information, and information includes characteristics and attributes about objects, living or non-living objects, and events on the surface of the Earth, right? So we are going to talk about the use of such space-time referenced information. Our emphasis is going to be on the use and the value of such data, how such data can be effectively used for gaining certain insights, making certain decisions. We are not going to spend a whole lot of time on the collection of such information, although I'm going to talk to you about some potential data sources, some technologies that are used in collecting data, and so on and so forth. But our emphasis would be on use. We are also going to, just as a basic kind of information for you, space-time reference, when we talk about some object or some event having a space and time reference, that reference can be at varying levels of granularity. For example, a space reference can be an XY coordinate. A space reference can also be a pin code area. A space reference can also be a state, and so on and so on, right? So more or less granular. A time reference similarly can be as precise or not precise as we want, right? Or what is available. And as I said, objects, when we talk about objects or features, we are going to talk about natural features, we're going to talk about infrastructure and people, right? And we are going to spend a whole lot of time on people and what kinds of information can be and are being gathered from people as we move for gaining a bunch of insights. And we're going to spend, I hope, towards the end, some significant time talking about COVID and how GIS is helping, or at least facilitating, COVID management, or can further facilitate management of COVID. So we're going to talk about all of that. Now, what we won't cover, and that is also important in case you thought about that, we are not going to conduct a training course on the use of a GIS software, right? You may know that there are a bunch of GIS software out there that are out there. In these 2 hours that we have, 2 or so hours that we have, we can't really train you to actually using a GIS software. If there is sufficient interest, we can follow this up with another session or a bunch of sessions talking about hands-on GIS software, but we are not going to do that today, right? So that's also something that is important. Now, as we get started, some very basic rules. Please, and this is from our experience of running such, webinars and workshops. I would appreciate if you can avoid speaking. Please keep your microphones muted at all times. Just keep an eye on that. It's okay if some of you keep your videos off. It's also okay if you make yourselves visible. I mean, it's good to see some real faces out there, but don't worry about that. As long as we are all together paying attention, and as long as you all are asking questions and all of that, that's good enough. If I ask a question, and I'm going to ask a few questions, simple or not so simple questions, please respond by typing out in the chat box, okay? And when you type out to everybody, not to me privately, so that we can all see, and that's important. If you have a question at any point, again, type it out. I may take the question right away or wait for a particular Q&A. And of course, we'll have a break in the middle, and there will be specific question and answer windows, okay? All right, so those are some very basic rules, nothing complicated. So let's get started. Now, I would like to start off with this image. I'm not, a history person or a specialist in history, but I enjoy certain historic artifacts, especially when we are talking about a GIS. It's good to start here. Anybody, any idea what this is? Any idea? This is very important, actually. Yeah. So Gopi says that it's a Mayan artifact. Okay. Yeah. I mean, it's historic, right? So what this is it's a clay tablet, which interestingly is a map of the world. which, as we know, it's the oldest surviving world map from the 6th century BC. And what this shows is the world is a disk that's surrounded by a ring of water called Bitter River. And since this originated in Babylon and in a certain part of Iraq, of current Iraq, Babylon is marked as a rectangle at the right end of the Euphrates and all of that. Now, what was the purpose here? The purpose here was, there could have been many purposes, but what we at least know is there have been, this has significance both spiritually, but it also has significance as an important map for those that generated it. And they in fact marked their own place and places nearby as a reference, okay? And to them, this was their world. And to them, there wasn't much beyond their own world, okay? So this is important. Now this map here, I mean, no more quizzes. This map here is a papyrus map from ancient Egypt, which was made, even earlier, 1150 BC. And this was actually a topographic and geological map that was prepared for a quarrying expedition, okay? And this shows a certain stretch in the central part of Egypt's eastern desert, okay? So what was the purpose here? The purpose was to assist in a quarrying expedition, right? And these are all preserved. More such maps. This is an ancient Silk Road map, which is a 30-meter long map painted on silk, dating back to the Ming Dynasty, right? 1300 to 1600 period. What's the purpose? What purpose does this map serve? It depicts the trade route, right? Across Central and West Asia to the Middle East, right? So it's again preserved, served a purpose to those that prepared the map at that point in time. Another map, much later or much closer to the current period, 1502, a Portuguese map maker, at least that's what we know, that this is the first map where we have the Arctic Circle, the equator, the tropics, and so on and so forth. Why was this made? For expeditions and so on and so forth. Another map, interesting, a road map of the ancient Roman Empire, right? With Rome at the center. This was made in the 4th or 5th century and 6.75 meter long. What does it do? What's the purpose here? The purpose is that it tracks public roads from the Atlantic Ocean to modern day Sri Lanka, right? Is this an accurate map of the roads? No, it's a schematic diagram as it seems, right, from this map. What purpose did it serve? Perhaps for navigating, not navigating, but perhaps for wayfinding. This served a purpose. This is from India. It's a Rajputana topographical survey, an original map back in 1868. Again, what purpose did it serve? Well, it's a topographical survey map, so it did serve their purpose administratively and also for infrastructure construction and other purposes. So what do these map examples tell us? Why did I start this discussion by throwing at you a few, apparently random maps from all over? Why did I do this? What do these map examples tell us? What do you think? Okay, so Prakhar says that humans have always tried to list the paths for ease of travel. Okay, so all right, ease of travel. Shashwat says that it talks about geolocations. All right, good. So we were trying to locate places. Again, locating roads are part of our effort at locating places. All right. Aarti says that it's an evolution of the world map. Tarun says directions. Others say planning for region to visualize the spatial distributions. best way to convey information, abstraction, and so on and so forth. So very good, exactly. So, we were trying to do something for a very long time using maps. What were we trying to do? So good, yeah, I'm reading all that's coming in the chat box. I'm not reading out all the comments, but that's good. Well, what this really tells us is that maps are beautiful to look at. But what is important for us in this particular context, as our discussion on GIS and other things gradually evolve, is that maps are useful, right? Maps always serve a purpose, right? And what is the purpose? Well, you can talk about visualizing and all of that, but visualization also has a purpose. We visualize something because we want to make certain analysis, right? Visualization is not different from analysis. We visualize because of for a certain objective. So two things, at least, which of course came up in what you just wrote, is that this is not new. Maps have been drawn for many, many years. And what is important is maps and spatial information that are depicted in or through maps have served a bunch of wide range, in fact, of purposes, starting from discovery of new lands, right, of new continents, to planning certain places, routes, serve the purpose of enhancing or facilitating trade, and also to start or stop conflict, right? And that's quite evident from all of these maps or examples of maps that I just showed to you. Now, why are these maps so useful? These maps are useful if you, sort of summarize all that we saw and, add a little more. In a nutshell, maps help us in multiple ways. They help us record the locations of certain places of interest, right? Again, we don't record places just for the heck of it. We record locations. Why? We'll come to that in a bit. To define boundaries, to administer, right? And we do that all the time. We keep doing that. To navigate, to conquer, develop colonies, or just to travel. To learn about the physical and social characteristics of a place, or even to preserve history, right? So maps help in any of these ways, or maybe many more reasons why maps are helpful. So let me ask you, what's your map connection? How do you use maps in your everyday life? And of course, we are going to go beyond maps, but maps are a good place to start because I'm sure we all use maps in our everyday life, but some of you may also be using maps in your own research or other professional work. How exactly? Can you just type out if there is a significance of map or maps in your life or in your professional work? Right, so Shashwat says to identify routes for travel purposes, right? So we use maps when we travel, sure. Prakhar says for checking reviews and deciding the food joints. Okay, all right, so that's good. What you're hinting at is that maps not only locate certain places, for example, restaurants and other things, but then those restaurants have certain information attached to them, right? How good are they? What kinds of reviews have they got, and so on and so forth, right? So we'll come to that, right? So Ashish says, Google Maps, to show the distribution of economic activity in my research. Good. So, Ashish shows the distribution of economic activity across space using maps for his or her own research, right? Okay, good. Mohanlal says for delivery planning. Good. So, we need to have a spatial, outlook in order to plan for deliveries. Good, right. Optimal networks for ride-sharing vehicles, science says. Yes, exactly. Bhavna says to identify the patterns of different economic factors across space. Identify, right? So all of these, there are these words, right, for identifying, for studying, for routing, and so on and so forth. So you're using maps and the associated information in maps for a certain objective, with a certain objective, with a certain goal. Rajiv Ranjan says natural resource management planning under NREGA, right? Good. I mean, that's one step further. You're using certain information and then using that information to analyze certain things and hence planning. Good. All right. Good. Priyank says to be the relative analysis of safe roadways. Good, right? So there are roadways, and roadways have certain attributes. I'm jumping ahead. Attributes attached to roadways. How safe is one roadway as opposed to a different roadway? And then you can compare them over space and make certain determinations, certain analyses, or even certain decisions about which roadway to make an intervention in, right? So good, right? So we are kind of we're getting an idea of where we are going with all of this. So this is good. Now, maps come in certain flavors, okay? And in the examples that you all gave, we were talking about many different kinds of maps, actually. So there are certain common map types or flavors of maps. The first, or the simplest, are general reference maps, right? And Google Map is, in a way, well, it can do more than this, but in a way, it is a general reference map. What do we see here? This is the IIMA area, and this marks certain, landmarks, right? So where is a mall, for example? Where are the banks? Where are certain other places of interest, restaurants, right? Cinema halls, and so on and so forth. So general reference maps provide information on locations of points of interest. Then there are thematic maps. And for example, there were some who mentioned here that I use maps to look at the spatial distribution of economic activities, to look at the spatial distribution of incomes, for example. So those kinds of maps would be classified under thematic maps, right? And here, what we see here is thematic maps with the spatial unit of analysis as a US state. And what we see here is a color-coded map which shows owner-occupied housing units. Okay, so what is the percent of owner-occupied housing units, the other being rented units? And this shows that there are certain states which have more versus some states that have lower, relatively lower percentages of owner-occupied housing units. Right now, is this a good visualization? Sure, it's a good visualization. Here, this is, you have there's the social explorer, which basically can be used to query or make such thematic maps very quickly. If you change this owner-occupied housing units to some other measure, right, you'll get a different kind of a map, right? You can even change the spatial unit. Remember, space-time, the spatial unit of analysis can be changed. Here you have a state, you make them smaller into, let's say, US counties, you will have a different map. What this will allow you to visualize is what is the distribution of, let's say, owner-occupied housing units. But why are we doing that? Now keep thinking. Of course, there is an answer. There's probably an easy answer. We are not just visualizing this distribution of percent owner-occupied housing units across US states or across US counties or other things just for fun. We're doing it for a reason, right? With a certain purpose. Now, what is that purpose? We don't have to answer that now, but there is a purpose to doing this. Now, these would be thematic maps. Now, this is another thematic map done in a different way. What does it help us, analyze, or at least to understand? Is the spatial distribution of full vaccinations, right? And this is from covid19india.org that many of us may be regularly tracking. Here, what it shows is that the radius or the diameter of these circles or bubbles are proportional to the number of full vaccinations that have happened. And why are we doing this? Well, at a glance, we know that there are certain places where there have been more vaccinations than other places, right? But then again, this is at what level? This is at the district level. Now you can always argue that, hey, there are some districts that have more population than other districts, so why not? I mean, there will be larger circles in those districts with more population. Sure, then you create a different kind of a measure, but per population, per capita, and you can make a different kind of a map, right? So these maps, thematic maps that map a certain theme or a certain variable of interest across space, again, serve a certain purpose. Now the third, there are topographic maps, and topographic maps contain what? They typically contain contour lines, which basically represent elevation. They can also, map human settlements, right? Where are places, built up spaces, roads and vegetation and so on and so forth. And these topographic maps are, we commonly don't use these maps, but then we may need to use these maps. For example, if you're deciding on a certain activity to spatially locate, and we may be interested in contours, we may be interested in staying away from or closer to vegetation, we may be interested in staying away from or closer to roads and so on and so forth. Right? But these are prepared generally by government agencies for administrative purposes and other things. Now then there are cadastral maps, and cadastral maps, again, we don't commonly use cadastral maps, but then these maps would be necessary, or forget about necessity, but these maps record information on land ownership, right? So these are land holdings, and there is associated information for each parcel on, there could be any number of information, right? I mean, who is the owner of the land, and the historical information on ownership, the area. There can be other information on elevations, there can be information on land use, there can be information on whether or not there are built up areas within those plots, and so on and so forth, right? So those are, again, maps that are commonly used for a particular purpose. And what purpose would this be for? Of course, record keeping and, clearly, management and administration of land. And then there are navigation maps, and typically navigation maps are also called navigation charts, which is, jargon. But the idea here is that, typically, for those who navigate in the waters or air, there are navigation maps with more detailed information on how to navigate through space, right? And then they're navigating. Let's not spend a whole lot of time. So what we know from here, from the different flavors in which maps are often presented, or we present, not are presented, but we present maps, that they are indeed, again, useful. They serve a certain purpose. And what I want to emphasize here, and we'll see soon, I'll gradually make this, it's useful to start simple, but the point here is that even if maps serve the purpose of visualizing, we visualize for a certain reason. And when we are visualizing, we are also analyzing and trying to make sense of something, right? So that's the use of maps. So what we understand is that maps are useful, and maps are not merely representations of select real features on the earth. So they are not only representations. What maps do explicitly, or how we use maps in our own analysis, is that they are recording, they do record, or they may record relationships between features, right? And they allow these relationships to be analyzed for a certain purpose. So for example, I may be interested in learning what are the, in a simple map, I may be interested in knowing what the locations of police stations are, or forget police stations, the locations of hospitals. Why? Because I may be interested in analyzing the relationship, spatial relationships between hospitals or healthcare centers and residential areas when I'm making a choice, a residential location choice, right? So maps record these relationships and allow us to analyze certain relationships for a certain purpose, and we can have many different purposes. And the point here is, and as we talk about geographic or spatial analysis, is that the systematic collection and systematic analysis of such spatial information that can be mapped, right, are often useful for solving certain problems or making certain decisions. And that gets us, when we're talking about analyzing, using such representations for, for spatial thinking and analysis, that's where we move from cartography, which is map making, to geographic information systems or analysis of geographic information. So when we use the word GIS, what is it? It's basically a system that involves the collection of, maintenance of, storage, analysis, output, and distribution of spatially and temporally referenced data and information, real information, right? So it's a system that involves a whole lot of things: collecting data, maintaining and organizing such data, storing it somewhere, representing it somehow, analyzing them, and then distributing for consumption of such spatially and temporally referenced data. And what GIS would probably, if there was such a system, and there are such systems, but what the idea here is that such systems would make it possible for us to understand certain natural or social processes, right, by understanding or analyzing the spatial relationships or even temporal relationships that were difficult in the past, right? So these systems are designed to make such meaning making easier for us so that we can make certain decisions. So geographic information systems, often they're called geographic information systems or geographic information science or geographic information studies or whatever you call it. They're defined in many different ways. It doesn't really matter, but it's useful to just read through what the definitions are. And of course, don't worry. I mean, you may feel that this is a little vague at this point, but as I said, the focus here would be on applications, and we are going to talk about a bunch of applications across different sectors so that you can see how such information is actually used. So what is GIS? Well, you can think about it as a powerful set of tools, as I said, for collecting, storing, retrieving, whatever, displaying spatial data from the real world that we can use for analysis. You can think about GIS as some sort of a computer database, right, that allows to capture, store, again, retrieve, analyze, display spatial data. You can also think about it as some sort of a decision support system that involves the integration of many different kinds of spatially and temporally referenced data in a problem-solving environment, right? So problem-solving again is important. So key is, as I said, analyzing spatially and temporally referenced data. So for example, let's look at this. Let's say we have a bunch of maps, right, that can be overlaid on each other. Look at the right-hand side of this right-hand side image or figure. So let's say we have a bunch of maps of the same area that can be overlaid on each other. What kinds of maps? We have a map of roads. We have a map of land uses meaning, whether it's a residential zone or a commercial zone or whatever. There are certain administrative boundaries. There is a hydrography map. There is an elevation map. There is an image base of the satellite image or whatever. And let's say we are able to collect such data, or we have the ability to create such maps and then stack those maps on top of each other. Now, if we are able to do this, what purpose could it serve? Would we just do it for representing roads, representing land use? Representation has its own benefit, but we have represented, right? We have visualized. Will it be useful for us? How can it be useful for us? Again, by analyzing the relationships between these different layers, analyzing the relationships between all of these features, by analyzing the relationships between all of these objects, how will it help us? So Pallavi says that places where the different maps overlap, let's say land use and hydrography, water management, and so on. So what Pallavi is probably, okay, let me read another one. Savan says, together they can be used to hypothesize certain research questions. Okay, sure. But think about it, more simply. We'll make it complex later on. But more simply, I think what both Pallavi and Savan are hinting at, and Mohanlal is also saying town planning, land acquisition, new infrastructure. Yeah, exactly. So basically, if we are to locate a certain activity, it can be anything. It is possible that we need not only need to look at not only not only look at where the roads are located. Well, that is important. Maybe we want certain proximity or not close to roads, but we may need to have other considerations, right? We may want to avoid certain boundaries, certain administrative jurisdictions, stay within or away from certain jurisdictions. We may want to avoid certain elevations and so on. So think about it as a multi-criteria decision making that we commonly do in spatial contexts, right? We do that all the time. We have many different variables and we are basically optimizing. Same thing here, where our decision making, let's say locating a certain facility, is not only based on closeness to roads or certain land uses, but its spatial relationship to a bunch of other spatial features, including all of those that we have listed here, right? So the idea here is that our power to collect these high or low resolution, whatever, these data, spatial data, images, events, features, and so on, in space and time allows us to better represent and visualize, which is useful. But moving beyond that, they allow us to combine diverse data elements, analyze their spatial and temporal relationships to make certain choices, to make certain decisions, and so on and so forth, right? Now, this is a very, very simple example. We'll make it more complex, trust me. So really quickly, again, I won't spend a whole lot of time here, but it's good for you to know that some of the major methods of collecting the kinds of data that we saw here, where are the roads, what are the land uses, where are the administrative boundaries, what are the elevations, and so on. Some of the methods that are commonly used are using, GPS systems and identifying locations of features, right? Remote sensing to identify the, to map the earth, right? Imagery and so on and so forth. And such images can be converted into identifying certain features and objects and so on and so forth. So GPS, advances in global positioning systems and advances in remote sensing help us in creating such maps, right? If you're interested, go and look at that. Lots of information available on the web, but that's something that we need to be aware of. The other thing that we need to be aware of is how is the data stored in a GIS kind of an environment. Data is typically stored either as vectors or as a raster data. So vector data are represented by points and lines and polygons, and raster data, as you can see here, are basically a bunch of cells, and each cell has a certain information, right? Now, here is an example. You can see here there is a real world image of something. I don't know, there is a road, and on the side of the road there is a building. Now that building and the road can be represented as a vector, where this building is a polygon essentially, and the road is some sort of maybe a line, right? It looks smooth, but it can be, a bunch of straight lines, right? Now, these are vector data, right? And this vector data can be represented in a GIS environment using, again, points and lines and polygons. But they can also, the same thing can also be represented in a raster environment where that area is divided into a bunch of cells, and some cells have information and some cells don't have information. And also we have a building and a road there. Now, what is important for us is that we not only have the locations, or we should not only have the locations, but we also need certain attributes attached to those locations, right? So for example, regardless of whether it's a vector or a raster, each element in the vector, you have a polygon and a line or a bunch of lines. Each element needs to have certain attributes attached to those elements, right? So for example, the building polygon may have a bunch of attributes attached to it. What kind of a building is it? Is it a commercial building? Is it a residential building? How many floors are there? And so on and so forth. Now, those information need not be static in time. Those information can change over time. I mean, the building can undergo, vertical expansion or other things. This road, which can have an attribute of how many lanes does it have, what's the traffic congestion like, and so on, and that can also change over time. Similarly, in the raster environment, every cell can have potentially a certain information attached to it, right? It is possible that all the cells containing the building may have the same information. It can also have a different information that locates, for example, which part of the building is that cell in, and so on, right? So there can be all that information that's attached to a vector location and a raster location representation. So Shashwat says, which is generally preferred specifically in the field of analytics, also which method is easier and cost effective to do? Well, there is, Shashwat, there's no easy answer to that. But then, there are certain spatial relationships that can be made using vectors better than rasters, for example. So for example, just making this up, let's say you have a certain state, and in the state, you want to know how many hospitals are there. Forget state. Let's say there's a district, and you want to know how many government hospitals are there in the district, right? So if you have to answer that question, what kinds of data do we need? Typically, we need vector information on, let's say, the boundary of a district, and we need the locations of all the government hospitals there are within the district, and then we can compute the number of government hospitals and aggregate them up and attach to the attribute of a particular district, right? Now, in order to capture the number of underlying government hospitals that there are within that district, you need a vector layer, right? Both must be vectors. Why? Because you are using a certain spatial relationship. What is the spatial relationship? Give me all those government hospitals that intersect with the boundary of a certain district X. And once you have identified all those government hospitals, give me the count of such hospitals, right? So certain spatial relationships, given your purpose, would be easier if you use vectors rather than rasters and so on. But then the same question can also be answered using raster, but rasters are essentially images, right? Or that you are analyzing. Now, what I want you to, so what we were basically talking about so far is that you have two things then. You have a feature location and you have an attribute attached to the location. So here, see, there is a US state map. So there are all these US states, but then these states are what? Each of them are polygons, right? Vector polygons, let's say. But what do those vector polygons represent? Those vector polygons represent the locations of those states. But we are not only interested in locations, we are typically also interested in the characteristics of locations. Now, what are the characteristics of locations? Those characteristics of locations are attached as attributes to each of those locations. So for example, here, the state of California has been highlighted, but the entire attribute table of all the states have been opened up. What this shows is, see, there are all of these, the attribute table is that there are all of these states. What is the name of the state? That's an attribute of the state, right? We see other variables here. There can be other variables attached to each of those features. What data can there be? There can be census type data, right? There can be what's the population of the state? How many population distributions by age? There can be some measure of incomes. There can be some measure of home ownership or rental or whatever. Now, once you have all of those attribute information attached to location features or feature locations, then what can you do? You can answer certain questions. If the question is, hey, create a thematic map of using a certain feature, can you create a thematic map? You can. And what is creating the thematic map? Are the locations creating the thematic map? No, it's the attributes attached to those locations that are being used to create the thematic map that I discussed earlier, right? So that's what we need to understand is when we say that, okay, the state of California or all the states have a certain attribute, which is, let's say, population, total population. These attributes can be derived or captured or aggregated up to the state level, in this case, from underlying data points of higher granularity, right? So, for example, there can be an attribute or a variable, which is, let's say, the number of old age homes, right? Now, how did you get the number of old age homes for each state? Maybe there is another data file, another layer, which has the locations of old age homes, right? Possible. And then the spatial operation that has been done is, okay, for each state, count the number of old age homes that underlie each state and attach that information or data point or variable to the attribute table, right? So every state gets the number of old age home data, correct? The other thing is many of the attributes can be time varying, right? It is possible that you have incomes for which year. As years change, income data can also change. So in that case, if this attribute table needs to be time varying, then you can have income year 1, income year 2, income year 3, and so on and so forth, right? Population year 1, population year 2, population year 3, and so on and so forth. So in terms of visualization or in terms of an analysis, you can also then look at what are, what's the population distribution or population, let's say, density distribution across states in year 1, but how has densities changed over time? What are the states where densities have grown more than other states? What are the states where elderly populations have grown or changed more in either direction from other states? So those are also determinations that can be done, right? Now, the other thing we also need to understand is that it may, feature locations can also be time varying. What are features here? The features here are states. Of course, state locations will not be time varying, but let's say if this was not a US map, this was a map of some other thing, right? Maybe, what could this be, right? Something where the area changes over time, right? Maybe, think about this, let's say a cluster of, food trucks, right? What are the clusters of food trucks, right? And you map the food trucks as your areas, and every such area again can have attributes. How many food trucks stand there? What are the kinds of cuisines that are offered there, and so on. Now those food trucks can change over time, right? The locations can change over time, the clusters. Then the locations of those geographic units are themselves time varying, right? So there can be time varying attributes attached to time invariant places, but it is also possible that places themselves are time varying. In that case, there will be multiple layers that tell us what are the locations of those same place elements, place A, place B, place C, and how they move or change over time. Right? Good. And Shashwat says, developing colonies, right? So their colonies can also change. Good. So in sum, what we discussed so far is that, maps with certain databases, which are attributes of map features associated with them. So, in our language, the language that we are using now, GIS involves maps, several maps with databases associated with them. And we've looked at what kinds of databases or attribute tables they have. And it's a virtual representation of the real world. And that is important. When we're talking about spatial analysis, we are interested in analyzing real world phenomena, right? So we may be modeling certain effects, but what we are interested in are real world information on people and places, right? That's important. So virtual representation of the real world. If you're not interested in a real world phenomena, then GIS analysis or spatial analysis may not be useful. Okay. So by this time, right, you may be thinking, or I expect that you should be thinking about what are some of the interesting questions that spatial data or spatial analysis modeling can help answer in your own fields, right? If you had spatial data, forget about whether you can have such spatial data, but if you had spatial data of a certain kind, of a certain resolution, would it help you? Would it help you answer certain questions that you would want to answer? Consider and think about that, and we may come back and get some of your thoughts, because part of what we're doing here, as I said, is for you to think about what kinds of research questions can you potentially have if you had spatial data, or if you conducted spatial analysis, how would your research questions, how could your research questions be addressed in a different way? Now, we'll come to some specific examples of how the same research question with and without spatial analysis can have very different results or findings. We'll come to that. Yeah, so for example, Sawan says, migration of laborers due to lockdown induced by COVID-19 in India. Absolutely, absolutely, right? So, migration is essentially and inherently a spatial phenomena. So if you had data on flows of people, one could analyze those migration patterns, migration trends due to the lockdowns, right? Absolutely. One can also analyze, after lockdowns were lifted, returns, right? Have there been fewer returns than the past, and so on and so forth? So those can also be answered. Rahin says to solve complex location-oriented problems. Absolutely, and we'll see a few, location-oriented problems that we are commonly confronted with. Prakhar says for creating best supply chain networks using shortest paths. Absolutely. And shortest paths through real world networks, right? Shortest paths using real world networks where we know the geometry of roads, and perhaps if we have also information on congestion levels and other things, we'll get even better at answering these questions, right? Shashwat says, to addressing various factors affecting agriculture crop yields across India due to climate change. Absolutely, right? So climatic factors and agricultural crop yield, you can make establish certain relationships. But then think about this, you can also establish such relationships spatially, right? Let's say you have a data set that has a bunch of regions, and all of those regions have certain environmental factors and have associated crop yields. You run a simple association and you get a certain, and what I'll show you, or at least not, even if I don't show you explicitly this particular example, but we'll get to know how that same analysis done without spatial thinking and with spatial thinking will have very different results, will produce very different results. All right, good. Let me quickly move on. Well, it's not exactly a quiz, but some of the questions that maybe you are thinking, and you should be thinking, we are not going to do justice to all of these questions, but I wanted to throw these questions at you so that at least you keep thinking and keep exploring. One question that should be asked is that at what scale are spatial data stored in a GIS environment, right? How do we, we have a software and we are storing spatial information. What spatial information? Let's say the outline of a certain building. At what scale is it stored? Well, typically there is no scale. It's all real, right? I mean, although you visualize it on your screen, but every feature, if it is georeferenced, it has a real reference point on the surface of the earth, right? So it's not a scale. When you have to print a map, you have a scale. But when you're thinking about, when you're analyzing geographic data, there is no scale. Everything is a real scale, right? At 1:1. The other thing that we need to think about is how can features on a spherical earth be projected on a flat plane? So what it's useful for us to know is that, well, since the earth is spherical, almost spherical, and since we are plotting points, roads or fields or buildings or anything, when we are plotting them, and since we're interested in relationships, we need distances, right? But then distances how? We have a spherical earth. So what you also need to keep in mind, or again, we don't have to settle this right now, but what you need to keep in mind is that since we are measuring distances and creating relationships on the surface of a sphere, typically we are looking at, when you're looking at distances, all we are interested in are angles from the center of the earth, right? So that's what we are interested in. That's what we get. However, if we are to analyze using meters and kilometers, what we need to do is that we need to project the spherical earth on a flat surface. So we often make those projections and we call them projected coordinate systems, which allow us to measure distances in meters and kilometers and so on. But so there are two ways of visualizing the earth and conducting these analysis is considering that the earth is a sphere and measuring distances as angles from the center of the earth, or projecting the spherical earth on a flat plane. And you don't have to project the entire world together. There are ways of projecting. You can select a particular area of interest and project it on a flat surface to minimize distortions and conduct analysis of relationships in usual units, meters and kilometers. So that's the other thing that you need to think about. And again, for those that are interested, go look at coordinate systems, geographic coordinate systems, and projected coordinate systems. All right. So a lot of information available out there, right? So my job is to direct you there. And the third thing is, again, something that I just mentioned in my response to one of your questions or comments was, we also need to think about that there are many different kinds of spatial operations that we can do. A simple operation is that, let's say, and you can read it on the screen, let's say you have surveyed 1,000 businesses across India and collected their addresses, okay? You can do that. Now you want to reconnect with those businesses that are in urban areas. What should you do? Right? So what is the operation that you should do? If you think about it spatially, and I'm just giving you a simple example, what you need to do is that there must be a map of urban area boundaries, isn't it? And there is a map that you have created where you plot all the 1,000 businesses and their locations, because you know the addresses, right? So you can pinpoint them more or less. And you have a map that has all the distribution of urban areas. So what is your question? Your question is, hey, give me on those addresses or those points that intersects with the urban area boundaries, right? And what are the urban area boundaries? Those are polygons. So what you're essentially doing is that you're extracting points from within certain polygons. And when you extract a subset of those points that intersect with or are contained in certain polygons, you have a subset, right? And then you have that. And once you have that, then you reconnect with them. So this is a very simple spatial operation. So once you think spatially, you will be able to easily derive methods to solve your particular question, right? Now, that gets us into, all right, so there are all of these things that we can do. So who uses GIS, right? And why do they use GIS? I'll skip this slide. This is too heavy. You can see that people from a wide range of domains commonly use GIS. Of course, why not? But let's look at some specific examples. Some of the top industries that use GIS, and forget industry, some of the fields in which GIS are commonly used include, for example, supply chain management. Now, this map over here, what this shows, and you can read, is, this looks at the speeds of delivery, right, based on route times, right? So there is a spatial distribution of speeds of delivery for various different routes. Now, once we are able to identify these speeds of delivery across different routes, you can see that you can make certain decisions of what kinds of routes to choose for achieving a certain objective. And what is the objective? The objective could be fuel savings and so on. Now, those that are involved in the delivery of fresh produce, for example, right? Agricultural products. GIS technology and such data can tell you, if you have that data, now how you get that data, we'll come to that, but if you have that data, you can, at least in theory, tell when certain fruits and vegetables left the field, what routes they traveled through, and what their quality upon arrival, and so on and so on. If, for example, you see that certain produce arrives unappetizing or not of a certain quality that you want to meet, then you can retrace these steps and identify certain parts or certain areas and improve them, right? So this is just a simple use case, but such problems can be solved through spatial data and analyzing spatial data. Insurance companies commonly use spatial analysis for making decisions. Why? Because we all know that there are certain regions that are more prone to natural disasters, earthquakes, hurricanes, floods, and other things. There are certain areas that are more to certain associated with certain social factors, propensity of crime, for example. Now, if there is data, and if you're able to identify those places, right, where certain risks are disproportionately high, right, then insurance companies can set coverage rates, spatially targeted coverage rates better. What kinds of data would they need to map risk levels based on whatever their products are? They could need data on the historical occurrence of hurricanes, for example, that could enable them to analyze the more or less likelihoods of hurricanes or cyclones and other things over space. Demographic data over space, we looked at those thematic maps, right? It is possible to identify certain places, and those places can be certain geographies, maybe pin codes, maybe districts, I don't know what, but it can give you information on, well, depending on demographic characteristics, can I predict what are the areas where people are more likely to get involved in car accidents than other areas? And then craft my products in a spatially targeted way accordingly. Right? So insurance companies or questions around insurance can be better answered, right? I mean, clearly it's getting a little better at what they're doing. Urban managers and policymakers use GIS data all the time. How or why? Because they are the ones that are interested in making land use plans. Where should I locate various activities? We talked about that. They may also be interested in understanding where are certain kinds of environmental impacts concentrated, right? Environmental impacts, certain pollution hotspots, other kinds of pollutants, water pollution, whatever. They may also be interested in identifying historic sites. Where are they located? Which ones need to be protected, and so on. They may also be interested in finding routes of emergency vehicles or hazardous vehicles, etc. What is the question here? One may be interested in this question that, well, if I have to identify a hazardous vehicle route, then maybe I should avoid concentrations of populations, right? So I should avoid high density areas, right? If I have to route trucks, let's say, I should probably avoid certain vulnerable populations or concentrations of vulnerable populations. How do you know? Again, by looking at the relationships between, in this particular example, roadways and population distributions. Not only population distribution, but population characteristics. The distribution, spatial distribution of population characteristics. You can also be interested in understanding or which are the intersections that are accident hotspots, right? What information would they need? Of course, they would need the spatial locations of intersections, but they would also need historical data, for example, on accidents that have happened, right? Yeah, I mean, do we have that data readily? Probably not, but can we have that data? Sure. And if we do have that data, is it going to help us in making decisions better? Absolutely. Banking, for example, uses GIS all the time. Why? For example, to find locations of new branches that need to be opened, right? By looking at distribution of population, political disturbances, climate, and so on and so forth. For making targeted marketing campaigns of certain products by looking at, again, the population distributions within close proximity or otherwise, and so on and so forth. Health and human services use spatial analysis all the time. Why? Because spatial information on population characteristics, population health characteristics, can inform them about health conditions and vulnerabilities or hotspots of health vulnerabilities across space, right? And that would help them in targeting certain prevention and treatment. Again, targeting meaning in a spatially targeted manner, right? Or even such, the geography of vulnerability can help identify places where certain awareness campaigns need to be done, information need to be spread, again, in a targeted manner. I'll give another, a more concrete example about that in a bit. So in order to do all of that, right, we looked at all the sectors that would commonly or do commonly use spatial information to make certain decisions. But then once they have spatial information, what kinds of analysis are they performing in general? All these different people across these different sectors, what kinds of analysis are they performing? They're performing one or more of these kinds of analysis. They're either determining relationships, proximity, or not. They are trying to describe locations and describe events. For example, what is the level of transport connectivity to a particular region, and so on and so forth. They're trying to detect patterns. Well, are there in my city or across space, are there certain concentrations of crime? They're trying to make predictions, right? Okay, are there some places where land use change, for example, would happen more rapidly than other places? And if so, I may be interested in getting close to those places or staying away from those places. And of course, they're trying to find best locations, best paths, and so on, right? So they are conducting these kinds of analysis, more or less, nothing more, in order to address their problems, make their decisions. So these analyses come in certain flavors that are readily available in some of the commonly used, GIS software. For example, terrain analysis can be done very easily. Once you have, of course, if you have the data, one can analyze terrain, the slopes, the contours, the curvatures, and so on and so forth. Why useful? Sure, if you are a developer, you may be interested in terrain, right? I'll come to geostatistics because we're going to talk about statistical analysis using GIS data in greater detail in the next segment. But think about this. Let's say we are interested in predicting environmental contaminant levels and their relationship with the incidence rates of cancer. So in a spatial way, what you basically have is you have a map of places or locations, right, where you have surveyed. So you have certain places where you know the environmental contaminant levels and you know, let's say, the incidence levels of rates of cancer. And you make some sort of an association, right, regression or otherwise, which basically tells you that what is the contribution of a certain environmental contaminant to increasing the likelihood of cancer. Once you develop that model, what this will allow you to do is, make certain predictions. Let's say there is another place where you know the environmental contaminant level. You can perhaps predict with a certain level of accuracy what is the likely rate of cancer there, right? So one can build such models using spatial data to predict certain events, incidence of something, in this case, incidence of cancer, right? So again, that can be done. One can do image classification. For example, satellite images can be used and some algorithms can be trained in order to extract land use information from satellite images. So for example, if there's a satellite image available, there are methods available or can be developed pretty easily to identify, hey, what are the agricultural areas, what are the built up areas, or get even more fancy, where are the parking lots, where are the parks, and so on and so forth, right? So those can also be done, and those are done using image classification. Now, once the image is classified, then that information can be used for many other purposes, right? Now, if you know where the parks are located, you can answer other questions by looking at the distribution of parks. But can you conduct spatial relationships from satellite images? No. You have to convert those satellite images into features, project them onto your map so that you can establish relationships between places or features. And then answer your question that, hey, I want to locate my new housing development in a place where there are a lot of parks. Right? And then, of course, we commonly do network analysis, finding shortest paths, or finding, distribution sheds, right? So the top left, top right, what this basically shows is that through the real network, what is the area that I can cover, let's say within 15 minutes, 30 minutes, an hour, right? Determining the optimal locations of certain, let's say, distribution centers, or finding out what are the roads that are more congested than other roads at different times of the day. And those can help in determining locations, routing vehicles, identifying where to invest, let's say in upgrading roads, adding lanes, and so on and so forth. There are many other examples, and I'll stop here in a bit. Now, governments and for administration, they use GIS for interesting ways. For example, what we see here is whenever a particular site is vacant and being redeveloped, what the local city government does is it automatically identifies a certain radius around that redevelopment sites and sends information about this redevelopment that is happening to all other properties that are nearby. Right? Why? Because if there is a redevelopment that is happening in your locality, you need to know. But then those that are far off may not need to know, right? So again, information dissemination in a spatially targeted manner can be done by, again, establishing certain spatial relationships. Similarly, the environmental health department here can identify certain hotspots where multifamily dwellings are, apartment buildings. Maybe there are some areas where apartment buildings are at a greater risk from what? Maybe earthquake risk, maybe fire hazard or whatever. Now they can use spatial information to identify places that need to be checked more frequently than other places and so on. Public transport agencies may use information. Now this is a map, which again, in transportation, people use all the time. What basically this does is, this is, let's say a city, and the city is divided into a number of small blocks, and those small blocks can be, you can think about it as pin code areas or whatever. Here, these are blocks. What this color shade gradient tells us is how many jobs are accessible using public transport from each block in the morning peak. So let's say if you are in a certain block, you can easily figure out, if you know the distribution of job locations within the city, if you know the public transport network, if you know when buses run and so on and so forth, you can figure out that if I am in this sensor, in this block, within 30 minutes of public transport travel in many different directions or in any direction, how many jobs are accessible to me? And if this is repeated for every block, you would figure out that there are certain places that are better connected to jobs than other places. Then the question is, why is it so? It is possible that it is so because of the unequal distribution of jobs, but it is also possible that it is because there are certain parts of the city that are underserved by public transport. Then the question becomes that, hey, then I need to make, in order to ensure spatial equity in job access, I need to do something. Well, you can do whatever. Okay, so I'll skip this, but then this is where I'll stop, and then we'll take a break, and then we'll come back. This is an example from healthcare where, again, this is a real study where they've tried to figure out the geography of opioid addiction. Well, opioid addiction, big deal in the US. What they wanted to know is, where are the vulnerable populations? Where are the affected populations, but where are the vulnerable populations, those that are predisposed to opioid addiction? How do we know? Well, we can look at what are the socio-demographic correlates of opioid addiction. We can do it in multiple ways, but one way to do this is that, well, okay, so who are those people who are most vulnerable? Okay, certain age groups, maybe certain gender, maybe certain ethnicity. Now you can look at where are these combinations of characteristics, where are these people located? Where are their, again, hot spots? And if you know, then certain health services can be, again, given limited resources, certain health services or whatever services can be targeted towards those places so that the target population, which is that are most vulnerable to get addicted to opioids, can be targeted, right? So you see, again, I hope it's sort of clear that once you have such spatial information, you can use such spatial information for a variety of purposes. But then again, we need to have a certain research question. We need to be able to identify something that we are trying to solve. And once we know what we are trying to solve, then comes what kinds of data do we need? And once we have such data, what kinds of relationships are we interested in analyzing? And so on and so on. All right, so we discussed a few contexts where spatial data can help. We'll look at even more contexts in a bit. But I want you to consider how, for example, GIS can be used, or spatial information and spatial analysis can help in, for example, disaster preparedness and response. Cyclones, for example, a real threat and a real problem in the Indian context. I would also like you to think about how spatial analysis can help in elections, and especially in redistricting contexts, right? How can GIS help? It not only can help, but it does help, right? So in redistricting efforts. So those are again more context, but for you to think about. The other question clearly is where to get such free data. Well, where to get such data is not the question. There is a whole lot of data that is priced. There are a bunch of private companies in India that are able to provide, quality spatial information data, from roads to features to socio-demographic data to health data, to locations of buildings and road networks up to the number of lane level and so on. So such data are available, spatial data, right? But then there isn't a whole lot of free data that are readily available in our country. Although in many other countries, for example, census data, which is, we know what census data is, right? So census data, socio-demographic data are available in map formats where you have the location or administrative boundaries and data attached to such boundaries, but we don't have them readily available, freely available, but we should. But then a whole lot of satellite images are indeed freely available globally. And why are they useful? They can be useful to convert those satellite images to land use data. That can be done, so that is quite readily available. Now, the OpenStreetMap project provides a lot of data, not only on roads, but also on many features that can be used. Google Map, for example, don't we open up Google Map and search for where are the restaurants near me? Where are the Chinese restaurants near me? Now, since those are information that Google Map is able to present to us in a map format, those data are also available for download using the Google developer website. And again, for researchers, there is a whole bunch of free quota. So Google developer and their APIs can be used to get a lot of feature information. For example, where are the ATMs located? Where are the parks? Where are the schools? Where are the hospitals? Where are the health centers? Those data can be captured. And for non-commercial users, for research purposes, the kinds of data that we need, there are ways to get that, right? Again, as I said, from Google Maps, Google developers, and such sources. But again, it's labor intensive. We hope that a lot of such data would have been readily available. For example, do we know the spatial distributions XY coordinates of all establishments, businesses of a certain size? We don't. I'm talking about free data. We don't. I mean, would that help? It would surely help. Should all municipalities in India, for example, or local jurisdictions, should they have their own GIS portal? For example, where are the sewer lines? Where are the water supply lines? Where are the local amenities and services? Should they have such open GIS portals? They should. Do we have them in a ubiquitous way? We don't. But then again, as the use of GIS or spatial information increases, we can hope that availability will also follow, right? The supply side will be taken care of, hopefully. So it's important for us to recognize the importance, keep using, and that's when we'll get more data, I hope. All right, so that's where to get free data. The simple answer is that there isn't a lot of free data, but it's improving. Right, so Deepak says, what could be the best source to find the location data of petrol pumps in India? Yeah, I mean, Google developers, right? Let's say when you go to a certain place and you say petrol pumps, Google shows you all the petrol pumps, right? So there is, so that data is available from Google Maps using their developer website. By writing a short code, you can download the locations for a certain geography, of course. If you want to do it for the entire India, that's going to be tedious. But for reasonable geographies, it's possible. Yeah, so Mohan Lal says, Map My India, sure, but you think about that, Map My India, the free versions that are available are static maps, are image files, right? Here we are talking about XY coordinates that we can project on a GIS environment. Is that data available through Map My India? Perhaps, or other providers, perhaps. Is it free? I'm not sure. So I'm talking about free data that researchers can use. So that's the conversation. All right, so what kinds of software can we use for processing spatial information and analyzing spatial data? ArcGIS is the software that is very powerful, but it's not free. QGIS is a software that a lot of resources are available. It's an open source free software that you can download. You can play around with QGIS. It's totally free, and there are a lot of resources available online that can help you navigate through the basics of spatial analysis using QGIS. You try it out using some toy data. Okay. So when you talk about spatial analysis for research, some of the considerations are, of course, that you need geospatial data. You need good geospatial data, and lots of it if you have to answer all the kinds of questions that you want to answer. The good part is that, well, those that are affiliated to educational institutions, a lot of geospatial data, even for India, are available through libraries that subscribe to or purchase certain geospatial data. And such databases are growing, including in our own institute. Which is going to be, moving forward, or even now, great resources for answering the kinds of questions that I mentioned and some of the other questions that I'm going to talk about. Now, but then, the more we use, it's going to create a demand for such data, and that's going to be useful. Okay. Now, again, before I go into some more uses and in a little more detail about we'll actually look at a few research papers and what kinds of questions have they come up with, what data have they analyzed, what did they come up with, especially in the COVID context. I'll come to that. But before that, let me talk about a few pitfalls or challenges of spatial data analysis. Okay, again, I'm not going to do justice to all the challenges because I'm going to sort of talk about them fairly quickly. But at least it's going to give you a sense of what are some of the potential pitfalls. The first pitfall of using spatial data is what we call the modifiable aerial unit problem. Now, what is the modifiable aerial unit problem? Think about this. Look at these two images, figures, and we'll talk about this. It's very simple once you know, but this problem can present itself in fairly complex ways, but this is a very simple example. And here we are talking about a case of retirement homes in the state of Alabama, okay? And here we are using 2000 US Census data. What is done here? Look at the two maps, the left and the right. The left map, the outlines, the administrative jurisdiction, whatever the boundaries, are of school district boundaries, okay? So there are school districts. Think about them as, again, pin code boundaries, any kind of boundaries, but here we are using school district boundaries, okay? And on the right-hand side figure, they are fire district boundaries. I mean, these are randomly taken for illustrative purposes. Now, see, in the state of Alabama, let's say there are 5 important cities, okay? So, and the cities are mapped. Now, the point is that the state wants to prioritize the development of retirement communities, okay? So they have some money and they have asked this question, okay, so there are these 5 cities, where should we build retirement homes first? Where should we build retirement homes next, and so on and so forth? Is there a city where we want to build retirement homes sooner than later? Then the question is that, okay, so what is the basis of determining whether a place should get retirement homes or not? Then the question is that, okay, we are going to look at the percent population over 65 years. What kind of data do we have? We have data of percent population over 65 years. Data is available at fine geographies. What kinds of geographies? Small, let's say pin code or zip code level, which are tiny areas, right? We have population with the tiny areas. Think about small blocks, okay? Many such blocks in a city, many blocks in a district, and so on. So those are the units which is producing the data. What kind of data is available? Total population and population over 65 years. And what they have done is, in the left-hand side figure, they have aggregated that small geographical areas information up to the school district level, a random school district level, okay? And they have, what will you get at the school district level? What is the total population and total population over 65? So from the underlying data at the smaller geography level, you aggregate or sum them up, you get the data at the school district level, and you have a certain percentage. And you create a thematic map of a 3 gradients, below 12%, 12 to 15%, above 15%, all right? Then what do you get? In the highest concentration of 65 plus population, there are no cities, right? But in the medium concentration, you have 2 cities, Montgomery and Columbus. The other cities are in the low concentration. But if the same aggregated up is done not at the school district level, but at the fire district level, you get an entirely different distribution, right? Right? Now, what does it produce? It produces that, okay, so if you have to build retirement communities or invest in retirement communities, go and do it in Mobile and Birmingham, very different cities. Now, what does this tell us? Well, by using different aerial units, so that is the modifiable aerial unit problem. As you modify your aerial units and you aggregate underlying data upward, you may get very different answers. Which one is right? We don't know. Well, we can argue that you shouldn't be using school districts, you should be using fire districts. Well, who knows? You can use something else. You can use counties. Okay, if you use counties, then you will get probably a different distribution. Should you use counties? We don't know. The problem is that these administrative boundaries are arbitrary, right? The fact, what kind of boundary should we use to determine whether retirement communities should be built in one city or the other? We are not sure what kind of an administrative boundary is most appropriate. And when we don't know what administrative boundary is most appropriate, we often use available administrative boundaries. What is available? These kinds of boundaries are available, county is available, but the problem is that what you need to recognize is that depending on the boundary that we choose, our answer or the result could be very different. Okay, so that is the modifiable aerial unit problem. The other problem is what we call ecological fallacy. And what is ecological fallacy? Ecological fallacy is produced, so for example, from spatial data. Let's say we have many districts in India, okay, and we know what the income levels of districts are, and we also know that what are the crime rates of districts, okay, and we run a simple correlation, and we see that relatively lower income districts are associated with higher crime rates, okay, so there is some sort of an association, lower income and higher crime rate. Okay, so let's say percent population that are lower income. So the greater is the percent population lower income, the higher is the crime rate. Now, that's one observation, which may be true, right? Then if we make this inference that lower income individuals then are more likely to commit crime, does that follow? Well, the answer is it doesn't follow, right? Even if lower income districts are significantly associated with higher crime rates, does not necessarily mean that lower income individuals are more likely to commit crime. But I can show, we can show you a bunch of cases where such inferences can be made and that can produce disastrous results, disastrous inferences. Okay, so that's the ecological fallacy. And if you think about it, you'll figure out why that is not the case, right? I mean, it is not, it doesn't mean that this is the lower income individuals in those places that are actually committing the crime. I mean, crime can be committed in lower income places for a whole lot of other reasons, right? Even when lower income individuals are not necessarily more likely to commit crime than higher income individuals. Even in that case, this particular spatial relationship can exist. Okay. Now, the other problem that arises out of spatial data is spatial autocorrelation. And what is spatial autocorrelation? The fact that when we capture spatial data for conducting, analyzing associations, spatial data may not be random. And what we know is that data from nearby locations are likely to be similar to each other or more similar to each other than data from faraway places. Now, what kinds of complexities does it produce? So let's look at this example. Let's say we are interested in figuring out let's say the associations between neighborhood level socioeconomic characteristics, neighborhood level amenities that are available, and housing price. Why are we interested in doing this? Let's say, what are neighborhood socioeconomic characteristics? Let's say income level, right? And what are neighborhood amenities? Availability of parks and playgrounds, availability of healthcare facilities, availability of educational facilities, and so on. Now, what do we expect? What would we normally expect? We can normally expect that housing price would be higher relatively in higher income places, and housing price would be higher in places with better amenities. Maybe there's a school effect. If there are better quality schools, more schools in a particular neighborhood, housing price would be higher there. If there are more medical facilities, better quality medical facilities, then all else equal, that can have a positive influence on driving up housing price, right? Can't we expect that? We will expect that, right? Now, who would be interested in knowing this? A developer could be interested in knowing this to figure out where to build and where the developer can charge a particular premium for better quality amenities or better quality surroundings, lower incidence of slums and other things. They may be interested in what is the contribution of amenities or contribution of socioeconomic characteristics to housing price, driving it up or down. No, so let's say for doing that, they collected a bunch of data. And this is the city of Kolkata, and they collected a bunch of data from all these dots. They collected a bunch of data, and for each of these points, and these points are a neighborhood, right? And what is a neighborhood? A locality. And for each locality, they collected data on housing price, they collected data on socioeconomic characteristics of that neighborhood, and they also collected what kinds of amenities are available, right? Quantity and quality of. Now, once we have this data, what can we do? We can forget about this map, and we can just have a spreadsheet, right? You have housing price, you have a bunch of socioeconomic characteristics, you have a bunch of household neighborhood amenities, and you can run a regression model, right? What will the regression model give you? The regression model will probably give you the associations between neighborhood amenities, socioeconomic characteristics, and housing price. What we may get is that one additional school drives up, all else equal, drives up housing price by X. One better, all else equal, if the average quality of schools are better, quality measured somehow, then housing price is a little more, right? And that is useful information for the developer. It could even be useful information for the government, but nonetheless, you can do that. But the problem there are that you run into a few problems. Why? Because the data, underlying data, is produced in space, right? There are some neighborhoods that are located closer to each other, and there are some neighborhoods that are located far away from each other. Now, what are some of the problems that can creep in the kind of simple non-spatial regression that you had run? Some of the problems that can arise is it is possible that the price at location I can be influenced by the price at location J, right? Why not? I mean, if there is a place where there are premium housing, the housing price in a neighborhood location itself can drive the price of a neighboring location, right? We don't know how far or whatever, but a neighboring location, the price can be influenced. The other thing that can happen is that the unmeasured variables across these locations that determine housing price can be correlated with each other, right? Why? Because places are located close to each other. For example, one unmeasured variable, I don't know, can be, people of a certain, of a certain educational background, right? Now, if these neighborhoods close to each other, then there could be a correlation between those unmeasured characteristics that drive housing price, right? In this case, that you have not accounted for in your model. And the other thing that can happen is that the price in place I can be influenced not only by the amenities and socioeconomic characteristics in place I, but also those same characteristics and amenities of a neighboring place J. Now, these considerations, the fact that price in one can be affected by the price in the other, and that can be more for places that are closer together than places that are farther away. The fact that unmeasured variables of nearby places can be correlated strongly or not so strongly depending on the distance. And the fact that my location, my price can be influenced not only by my amenity, but the amenity of a neighboring location, which is in my data set. Those are not accounted for in the model that you just estimated, right? So the point is, I'm not going to the detail, but those effects that are unique to spatially captured data can be addressed using certain methods, right? And what we need to know is that those those interactions exist, and those interactions may need to be addressed using certain simple ways to address such interactions. All right, so these are just certain problems or challenges that exist in data that is spatial in nature, and therefore such data that is produced spatially may not be readily analyzed using non-spatial approaches. And that's something that we need to keep in mind. Well, how do we keep in mind? Well, if somebody produced this data and ran a regular OLS, that may just be right, but we should be able to recognize that, okay, or hey, there are these problems, have you accounted for them? The other thing that we need to know is, all right, maybe there is across the city of Kolkata, maybe there is we have accounted for such interactions, and maybe we found that an additional school in the neighborhood within a certain radius drives up housing price by X. What we also need to recognize is that, okay, does the school effect on housing price, is it uniform across the city of Kolkata? And the answer is maybe not. So a separate set of methods, which we commonly call geographically weighted regression, what it allows us to do is it allows us to take into account the fact that the effect of a certain independent variable on the outcome can vary across space. So for example, in this example, what they wanted to figure out is that, let's say this is a certain city, and the city is divided into a bunch of, make it up, bunch of pin code areas, and each pin code area has a bunch of attributes. What they're interested in as the outcome variable or outcome of interest is what is the public transportation usage rate. Let's say, what is the proportion of people who use at least one public transport trip in a month, that percentage, right? Let's say that is the outcome variable. And what they're in, the independent variable of interest in this case is the proportion of low-income households. So the idea here is that if you run not an OLS, let's say you run a spatial regression, and you figure out that, okay, if the proportion of low-income households increase by X, I hate to use increase, but if there is an X, whatever higher percentage of lower income households, then all else equal, what is the association, or what is the increase or whatever decrease in proportion in public transit trips, right? So maybe what you will find here is that the more is the low income household proportion in a particular place, the higher is the public transportation patronage, right? Because again, let's say low income people use public transportation more. Now, if you use data from all of these smaller geographies, pin codes or whatever, and you run a regression, and taking into account all of the interactions, what these people got is that a coefficient of, let's say, 0.005 or something like that, or 0.05, I'm forgetting, 0.005, which is that there's a positive association between low-income households and public transportation usage. Fair enough. Now, what they're saying is that that effect may not be uniform or equal across space. And what this geographically weighted regression tells us is that, all right, that effect itself could vary over space, okay? And here we have some places within the city where the low-income household effect on public transport usage is more or less than the overall effect. And that is what is mapped over here. So the yellow places are places where the effect size of low-income households are more than the average effect, and the red places are places, in fact, there are some places where there is an opposite effect, right? So those can be, so the geographically weighted regressions allow us to look at the variation in effect of a certain regressor over space. All right, so again, if you have any questions, please do mention in the chat box. Let me quickly move on to discussing some ways or some recent papers that have come out and with that basically highlight how COVID management is being facilitated or helped by spatial analysis and GIS and other things. Now, why should GIS help in COVID-19 management? Well, that is probably a no-brainer because we know that the spread of infectious disease is a spatial process. As people move, they carry with them the disease, and therefore, the spread of the disease is spatial, and therefore, geospatial data should help in understanding and perhaps also responding to the pandemic, and that is indeed so. Now, what I've done is I've divided the use of GIS in COVID-19 management into certain blocks. So the first way in which spatial data or GIS is using or is helping in COVID-19 management is the fact that spatial data infrastructures are helping in surveillance and data sharing, right? And that is something that we all know. And we all know that these interactive web-based maps, dashboards that are providing us with real-time, near real-time information on cases, on mortality, on recoveries, on vaccinations, and all sorts of things. And in some places, even the availability or the lack thereof of personal protective equipment are enabling us to visualize and hence direct efforts in certain places as opposed to other places, right? For example, it can be as simple as in a given campus, and here this is the University of California, Berkeley campus, where they have, what have they done? They have just done a real-time or whatever map of building locations, and they are tracking which of the buildings are being disinfected or have been disinfected or have not been disinfected. So this can be as local as a campus and identifying places that have been disinfected on time and not disinfected on time, and how can that help? I mean, you know how it can help. So this is very, very simple, right? But it can be a little more complex than this. And so let me stop share and share my browser screen just a minute. Okay, so here you see, so this is data from SafeGraph, and SafeGraph is a company that collects and processes and analyzes a vast amount of human mobility data. What this dashboard is basically showing us is over time, you select a particular state in the US. Well, we don't have such a dashboard, so I can't show you an example from here in India. But let's say we choose a particular state and we choose, I don't know, sit-down restaurants. What this is enabling them to track, and this data is not produced as a report by government agencies, or this is not a report by individual restaurants. This data is generated by tracking individuals and their cell phones in many different ways over time. And of course, this is aggregated, and therefore, individuals cannot be traced. But what this is essentially doing is, if you can see, in this state, you look at these graphs on the right-hand panel. Here you will see sit-down restaurants over time, and this starts from March in 2020 to July, pretty much today. What this tells us is, and it starts at 1, which is, to pre-pandemic times, how much have sit-down restaurants footfalls, and this is a footfall data. Footfalls in sit-down restaurants in that state relative to pre-COVID times, how have the trend been through the pandemic? And where are we now? Are we at pre-pandemic levels or under pre-pandemic levels, and so on and so forth? And this is for many different kinds of establishments, sit-down restaurants, bars, coffee bars, supermarkets, and so on. Now, how has this data been generated? I'll come to that in a bit, how this kind of a data has been generated. We won't go into a whole lot of detail, but I'll still try to explain. And here you see, the same thing, change in foot traffic to sit-down restaurants in the state of Maryland, how it has changed over time, and now whether or not it is at pre-pandemic. And here you can select other things. So what this is doing, this data that is generated from human mobility data, tracking such individuals, are being aggregated, and these are being used for, well, I mean, can it be used by decision makers to figure out whether or not businesses have economic activity has returned to normal or not? Yes, can be, right? And it can also be used to analyze, for example, the relationship between certain kinds of pandemic management efforts and reduction or increases in footfall, and how that varies over different kinds of establishments and so on. All right, let me go back to the presentation. Okay, all right, so that was that. So such spatial data infrastructures, why is it spatial? Because it is actually giving us data for certain states and for certain kinds of establishments, comparing footfall levels with pre-pandemic with pre-pandemic times, and also compared to other time points in this pandemic period, right? So that's helping us. Now, the second way in which spatial data has helped is population and mobility data. And somebody mentioned about mobility data and migration of people, mobility of people over space, and how such mobility of people traces are helping in analyzing the spread of the disease or managing the disease. So for example, this paper, it looks at the effect of human mobility and control measures on the pandemic in China. Now, what they have found is they show that travel restrictions from Wuhan, where arguably the pandemic emerged, travel restrictions out of Wuhan in the early stage of the outbreak was actually helpful in reducing the number of cases in other provinces of the country. So what they have done is here, if you see the top graph here, what this traces human mobility data using Baidu data, right? And if you see here, the red line, the vertical line is when travel restrictions in Wuhan was implemented. And this was on January 23rd, 2020. And at that point, you will see, if you look at the 2020 curve, and this is some sort of a sum of all kinds of, migration out of Wuhan. Clearly, after the travel restrictions started, migration out of Wuhan dropped significantly. Right, and they have compared it with pre-pandemic 2019 data, clearly it dropped even below the 2019 levels. Panel B, it basically maps the movements from Wuhan to other provinces in China. So if you look at, as time progresses towards the right, there are fewer travel out of Wuhan to other provinces, right, for good reason. And clearly after the travel restrictions started, very few traveling out of Wuhan. And the lower panel, panel C, what this does is it maps the correlation between incidence of COVID in Wuhan and the incidence in all other provinces where migration was happening. And clearly, right before travel restrictions, there was an uptick, which basically says that high correlation between rising cases in Wuhan and rising of cases in other provinces where people have migrated to from Wuhan. And right after travel restrictions started, there is either a flattening or some sort of a fall, and fall over a certain period of time, right? Which shows that travel restrictions actually helped in break that correlation between Wuhan and the cases that were happening there, or whatever the daily cases or weekly cases, and the cases in other provinces, which basically says that that correlation got affected, right, by the imposition of travel restriction. And how did they do that? By tracking people that moved out of Wuhan over time, and by looking at spatially at the various other provinces where these people were traveling to. So basically, if we go back, they argue that here we show that travel restrictions are useful at the early stage of an outbreak where it is confined to a particular area, right? But what they find is travel restrictions don't have such a large effect at as the pandemic progressed. Now, staying on to the same theme, which is how can population travel and mobility data help? But the primary question is that how is population travel data or mobility data captured in the first place? And that gets us into, for example, what this paper talks about is how SafeGraph data that we just talked about is used to analyze these population flows. So essentially, SafeGraph combines by purchasing a whole lot of mobile phone trace data, which gives them user trajectory data, right? And they collect all of that data. And when you collect all of that data, they get information of people visiting a large number of places. Now, how do they know? Well, they know a person. They may not know it's me. It can be anonymized, but they know where I am. How do they know where I am? These places of interests can be identified. For example, if there's a pattern in where I spend nights, most likely that's where I live, right? If there are certain places using Google Maps and other places, you would know whether where I'm going, how likely is that place to be a restaurant or some other place. So by finding those patterns, they are able to compute flows between places of interest or between certain geographies. Here they look at census block groups or census tracts or whatever. So they actually are able to compute flows between places of interest, visits to places of interest. In fact, they're able to relatively well, estimate crowdings at certain places of interest and so on, right? And then they are able to aggregate such data, as you can see, the green panel here, track to track travel, county to county travel, state to state travel, and flows, right? And of course, they use certain weights to sort of bump up their sample to have an estimate of the total population, the likely total amount of flows. So they do all of that. Now, once you do all of that, what they are able to do is, in the left hand image figure, what they are able to map are the weekly population flows and estimates of weekly population flows between states. Next, weekly population flows between counties, which are within states, let's say districts, and also weekly population flows between smaller geographies within a particular city, right? So what this enables us to see and perhaps to analyze and perhaps to also make decisions about where are these, travel, happening, right? And that can again be associated with, correlated with, the relationship between pairs of regions and whether or not the cases and other things are moving parallel to each other or moving together, right? It can also help analyze whether certain travel restrictions are working or not working, right? Whether there are certain places where a lot of travel is happening, and using some logic, one can determine that, hey, something needs to be done to reduce or facilitate travel between certain pairs of regions, right? So those kinds of analyses can be done, have been done. The third way in which spatial data have been used is for digital contact tracing, right? Because we know that conventional contact tracing that involves identifying, contacting physically people are difficult. People have proposed ways of contact tracing. So, there are a bunch of proposals of applications, mobile phone-based applications that use this particular, if you look at this figure, basically what the contact tracing app, it does is it keeps a memory of proximity of contacts, right? So proximity of cell phones, right? Cell phones that have come close to each other, and they keep memory of that, right? And so what this figure shows you is that, well, when I'm at home, if I am person A and I was close to a person B, well, that person B need not be known, but the person B's cell phone was close to my cell phone, and that can be known. I now travel in a train where I came close to cell phones C and D. I go to work where I was close to some people, but nearby some people, and then I come back home. Now, when I get, when day 2, I have fever, right? Then what happens is that instant signals are sent to those cell phones that were close to me across space for the various activities that I was involved or engaged in over a certain period of time. It need not be day 1, it can be day 0 or day -1, whatever. And they automatically get, information, or at least notifications, to self-isolate for 14 days and so on and so forth, right? So basically, the idea is by targeting recommendations to those at risk, they argue that epidemics can probably be controlled well. And they have a bunch of people, and this is not the only one, who have proposed such applications that are able to do that. And the argument is that if a large number of people, right, are able to adopt such applications, then we can perhaps show, and perhaps it is indeed true, that pandemic management can be facilitated, can be better. Now, the fourth way in which GIS is helping in COVID-19 management, or can potentially help, is by integrating geographic data in COVID-19 modeling itself. Now, what do we mean by that? In fact, there have been a bunch of studies that have looked at the spatial associations of COVID-19 cases or mortality. What do I mean by spatial associations? They've looked at the socioeconomic and the environmental characteristics that are associated with higher or lower prevalence of COVID-19 cases, higher or lower rates of mortality, and so on and so forth. People have evaluated whether income levels and income inequality are associated with high versus low COVID-19 cases deaths. People have looked at whether temperature and humidity plays a role. People have looked at whether our exposure to fine particulate matter, air pollution exposure, whether it aggravates the incidence of the disease or deaths, severe cases, whatever, and so on. So how have they done it? They've essentially, if there is spatial data available on the distribution of incomes, distribution of income inequality, distributions of temperature, humidity, you can think about this, you know, as a starting point, that one can think about some associations, right? Well, there are some places where there is more income, less income, medium income, and there is a separate distribution of cases, more cases, less cases, medium cases. Well, is there a relationship between income distributions and case distributions? Is there a relationship between temperature or a pollution distribution across space and the geography of cases and deaths? Well, the next question is that how do you associate? Well, that's the next step, but at least you can think about evaluating such associations. And people have done that, and they have found that, you know, all of these bullets are in fact effects that have been studied and that have been, and they have found, you know, statistically significant effects of these factors in aggravating or attenuating the cases and deaths related to, you know, COVID-19 cases and associated deaths. They have also studied that, remember the geographically weighted regression, what they've also found is that, okay, income has a role to play, but then the effect of income on COVID-19 cases, that effect size can actually vary over space. There can be some places where the income effect is more pronounced than other places, right? And that have also been studied. So for example, this paper in a really good journal, what they have found is that yes, it's a no-brainer that the distance to the epicenter of the disease is a strong influential factor. And they have done this, you know, using data from China. They found that the distance from the epicenter is strongly associated with the number of COVID-19 cases, and right. So the more the distance, the fewer cases, all else equal. But they've also found that the presence of subways, which is, you know, let's say underground metro rail, wastewater, residential garbage, and all of that, and they have mapped the locations of unmanaged wastewater, you know, poorly maintained residential garbage disposal facilities, and you know, and that again, spatial, you know, the locations, if you can map them, and you can separately look at the distributions of COVID incidents and relate them. And by relating them, they found that, okay, so these are features that play a role, not play a role, but at least they're positively associated with virus transmission, right? So they found that. A different study that looked at COVID-19 incidents in the United States, what they have done is, remember again, the geographically weighted regression, what they have done is, well, household income plays a role. And here they have looked at all counties across the US, and I think counties, I may be wrong, but you know, small geographies. What they have found is that yes, on average, household income plays a role. But then again, the contribution or effect of household income varies by space. So if you look at the income and income inequality, both varies obviously. So if you look at household income, the top panel, you will see that there are certain places in certain states where the contribution of household income or the role of household income in explaining a COVID-19 incidence rate is more than some other places, right? And they have basically mapped. And you know, if we continue this discussion, we can discuss, you know, why this is so, and if this is so, what should be the policy response, and so on. A different study, staying with the same theme, which is geographic data and COVID-19 case and death modeling. This study, they looked at New York City, and they tried to analyze the role of walkability and other things, but walkability mainly in explaining the social ecology or, you know, incidence of COVID-19 cases and deaths per 100,000 population. So this here is the distribution, spatial distribution of COVID-19 cases per 100,000 and our deaths per 100,000. What do we see? There are certain places where the incidence rate infection rate is more versus less. Again, in some places, the death rate, mortality rates is more versus less. The disease-specific mortality rate is more versus less. Now, why is it so? There can be many different reasons. They have looked at whether there is some relationship between walkability of those places and these rates. And what they have found is, if you look at this present research examined, and those smaller boundaries were zip codes, pin codes, right? They looked at 177 zip codes and the prevalence of COVID-19 prevalence of and deaths associated with COVID-19. And what they found is walkable zip codes had consistently lower prevalence and deaths associated with COVID-19. Now, more walkable, less COVID-19 deaths. Well, one can argue that why is this the case? It's also possible that the more affluent neighborhoods are also places where there is better walking infrastructure, so there could be an income effect and all of that. Now, they looked at something else. They looked at, what are the factors that are that have brought down COVID-19 cases and deaths? And they figured out that geographical mobility restrictions or lockdowns played a role in bringing down mobility and bringing down COVID-19 cases and deaths. What they also found is residents in wealthy zip codes and walkable zip codes were able to limit their long distance geographical mobility across the region. Why? Because walkable, they had access to a large number of amenities close by, right? They were wealthy, and therefore they had walkable infrastructure close by. And so these were the places that were actually able to bring down or associated with lower or larger reductions in cases and deaths in response to lockdowns, okay? They also did a spatial lag regression. Remember those regressions that take into account spatial interactions? They figured out that indeed walkability was a robust predictor of zip code level prevalence and deaths and the trends in prevalence and deaths over time. But of course, walkability in itself may not have caused, again, walkability is associated with a bunch of socioeconomic factors, as I mentioned. Now, again, I'm not going to spend a whole lot of time. We're almost close to, we have to end soon. But this is, again, a study that, one of my studies with one of my colleagues. Here we looked at the distributions of population densities measured in many different population densities, job densities, building densities, measured in many different ways across US urban areas. And we tried to figure out the role of density in COVID-19 infection rates and mortality rates. And we also wanted to compare the density effect with the lockdown effect, meaning what effect has different durations of lockdowns had on infection and COVID and death rates across these places over a certain period of time early on in the pandemic. And what we found is that density plays a role, but then lockdown also plays a role. And we also found that the lockdown effect varies by different density measures. Basically what we found is, places that are highly dense, lockdowns have a larger impact on, bringing down infection rates and death rates than places that are sparsely populated, right? So again, the idea here is how can we use geographic data in modeling or understanding COVID-19 infections, deaths, and so on. The fifth, perhaps the last, and kind of analysis that we can that is relevant in the COVID-19 context is to investigate the geography of health disparities associated with the pandemic, right? So, if we can map and analyze the landscape or the geography of vulnerability, right? The populations that are more or less, vulnerable to the disease, if we can find the geography of availability or the lack thereof of healthcare resources, governments can be better prepared in targeting efforts at either imposing lockdowns or augmenting healthcare infrastructure and so on in a targeted fashion. And again, a bunch of studies have actually done that. And this is, for example, a study that looked at the Brazilian healthcare system. They looked at over 5,500 municipalities, and they looked at, they basically analyzed many different scenarios of, more or less, decreasing social contacts, increasing the availability of healthcare systems, increasing the number of beds or whatever. So they looked at many different scenarios, 5 scenarios you can just read. And I'm not going to the detail of how they did it, but what they tried to figure out is that for all of these different scenarios, and each of these scenarios are associated with different kinds of policies or investments, what would be the likely effect on the number of beds that are available in those municipalities, right? And so they looked at whether they're going to have enough number of beds or whether they're going to run out of beds and so on. Well, what their analysis shows that if business goes as usual, at that point in time, based on whatever study period they use, they predicted that a large number of municipalities, as you can see, are going to run out of beds by varying numbers. But at the other extreme, what they found is that, hey, if we go ahead and with a 50% increase in the healthcare system defined somehow, we're going to do a relatively good job at a number of places, a number of municipalities. Right? So they evaluate. So again, this enabled them to evaluate various different policy measures, various different investments, and its likely impact on the healthcare infrastructure. All right, so that's, again, gives you some sense of how spatial data, spatial thinking, and spatial analysis, done well or done simply just by looking at patterns, visualizing, or by doing more rigorous kinds of analyses, can help in, or have helped, or at least provided a number of good insights in managing the disease. All right, so I'll stop here, and I can emphasize, sort of revisit certain issues, or feel free to ask questions. You can raise your hand. I mean, I won't say you can ask questions. We can discuss, and so if you have questions, you can type it out, or you can even raise your hand, and you can ask your question or make your comment, or if you want to discuss anything from your own experience, or if you have a suggestion for others, comment for others, please feel free.
Hello, sir. Can I ask one question?
Rajat, go ahead. Yes.
Sir, actually, I just want to clarify this thing, how to use 2 or 3 map layers one upon each other, like finding out the clusters of greater than 1, less than 1, or something like. So we need to put up 3 map layers. So how we can go with that?
Yeah, so you need 2 or 3 map layers, and the GIS environment allows you to analyze associations across layers. So let's say simply, you have a road layer, and you have let's say you have a metro stations layer, and you have a different layer that maps hospital locations. Yeah, well, you can ask a question that, what are those metro stations that have at least one hospital within walking radius, let's say 250 meters. Now, if that is a question, that question can be answered using the data that I just discussed, that just explained, in any GIS environment. Does that answer your question?
Yes, sir. Okay.
Yeah. Gopi?
Yeah. So this is an interesting discussion. Thanks for sharing this. So I'm from EPGP, so this was a bit of a very interesting one. One thing that came to my mind is the biggest problem on applying geospatial information in India is to bring the sensors to every person in our country. So yeah, we have the satellite data to get the geographic information, but the other details like the people moving across or the people data, demographics, that requires some kind of an electronic or some kind of a methods in the hands of people, either directly or indirectly, and then track it with this geospatial data. But given the current penetration of technology amongst the population of India, that is a big challenge. So outside the technology, is there any other smarter or other means which we can leverage to achieve this?
No, so if you're talking about data, as I said, census data is typically, let's say census data available at a small geography level, right? Now, a map, let's say a map of all wards, okay, and associated attribute table of census data at the ward level, that is available. Well, it's not freely available, but there are products that are available that allow you to get that information. So census data, when we talk about census data, we're talking about population characteristics, right? Social demographic data, right? Socioeconomic demographic data. So those data at the small geography levels in the form of a map with associated demographic information, census linked information, is available, okay? There are libraries that subscribe to them or have purchased such data that can be used. That's one. The second is you mentioned about our human flow data available. Now, for good or bad, this pandemic opened up a revolution in this open mobility data, right? And the kinds of data that I use some papers. I mean, this is not a data that I manufacture, but I myself used, but some of the studies that I highlighted that used such data, similar data are available in an Indian context also. For example, one example, again, there are many such data sources, but Facebook has a program or has a data for good initiative. And this Facebook's Data for Good initiative provides this human mobility data across certain geographies. And there is some data available for India also. So some analysis can be done. Now, Google has a lot of data, including, I think, in India, in Indian data, where they have tracked travel of people to certain places of interest, parks and playgrounds, maybe restaurants and other places. And they have used an index for various cities. That index gives us what is the level of travel, human mobility to those places of interest relative to pre-pandemic times. So it's not that we don't have data for India. We do have data for India also. Now, I think the last question that you asked is, the other thing is, again, as I said, places of interest, if you want to know, and somebody asked, data on, petrol pumps, right? Or ATMs. Again, Google developers and other such, facilities can be leveraged by researchers to figure out or find out and download or whatever you call it, the locations of these places of interest quite easily, right? And so it's not that we we don't have access to data. It's just as that we don't have access to, we're increasingly having access, but we don't have a whole lot of access to ready-made free data for any kind of information that we need. That is not available. And the other part that is not available, as I said, is that every city, so you know, Ahmedabad, the city of Ahmedabad should have a GIS data repository, ideally, where we have GIS linked information, you know, map information for administrative units, information on where are all the schools, where are all the hospitals, and where are all the utilities, where are all the, you know, electric substations, and so on. There are many countries where cities systematically have such data and make such data publicly available, because such data need to be publicly available, right? I mean, there is no, it's not proprietary data, right? So we surely need to go, you know, have a culture of creating such data, and we have huge opportunities. You know, we have the Smart Cities Initiative. One of the, you know, and the smart cities are collecting a large amount of spatial data for their own planning and infrastructure investment purposes. It will be immensely useful, and we need to advocate for making such data available to the public and to researchers so that we can answer a whole lot of questions, right? And the more we answer, the more we know. So there is a huge potential. I mean, I think we need not be too worried. If we have a question in mind, it is possible, it is highly likely that we will be able to get such data even in India. Right. So Tarun asks, what role GIS is going to play or help in shaping up the delivery of drones and flying vehicles? I don't know. I mean, probably it's not going to be too different from, you know, delivery planning for on roads. I mean, maybe for roads it's even more difficult. You have to navigate through congestion. But for, you know, shaping up delivery by drones, I don't know. We need other kinds of facilities. There are location challenges for facilitating zones and flying vehicles. Where do they land? So yeah. So there are questions around that. Shashwat mentions, will it be possible for you to share a link of the video, how to use GIS data into analytics using tools as applicable? Sure. I mean, to share a link or video where you can actually see how to use GIS data. Oh, okay. So you're saying, you know, sort of hands-on, using data and doing analysis yourself. I can't direct you to some videos for doing that, but there are many such videos that will at least give you a head start into using a QGIS, or which is free, to download it and trying it out. I'm sure there are many online resources that are readily available. You should be able to find very easily, very easily. Right, and Ruturaj says, how can we use GIS in people analytics space? Any example? Well, so what do you mean when you're saying people analytics? What kinds of questions? So it has to start with a question, right? So what is a question of interest? You know, the rule of thumb is that you start with a question and see what kind of data and analyses are useful to answer that question, right? So what is a question, Ruturaj?
Yeah, sir, basically wanted to see how I can relate GIS or mobility with the attrition or the performance of an employee. So something kind of analysis if we can do.
Yeah.
Using GIS. Maybe
I have to think about
mobility
that
has
question.
mobility has a lot of factor on the employee or the performance. So
right.
Just wanted to check if we have any example.
Not right now. We can think through. But I think the bigger question is that is spatial data even necessary to answer your question? And the answer to that could be no, right? That's also, we need to be open to that. I mean, we are just saying that in some context for understanding certain phenomena to analyzing certain problems to make certain decisions, spatial data can help. But there are an equally large number or even bigger number of research questions or problems that can be addressed without spatial data, right? So we need to be open to that also, I think. All right, so we've hit the 7:45 mark. I think we can end here. Thank you all for joining, and I hope that the discussion that we had today will at least sort of make you explore a little more on whether you can and how you can use, or if you need to use spatial data for your own answering your own questions, and possibly it can even have stimulated some new research questions, right? So, and if that is accomplished, I think this would be a success. So, so keep exploring spatial data, and hopefully some of you would be using spatial analysis in your own work, research, or profession. So keep exploring. All right. Okay. Thank you. Let's end the conversation.